So when we plug in 5, what's the issue? The denominator is 0, right? So how can we get rid of the denominator being 0?
Multiply the top by r minus 5 to the negative 1.
R minus 5 to the negative 1. Now just move it up to the top. So I'm thinking of,
But if you're multiplying with that function.
well, so what's the question asking? So take a step back here. There's some information you don't know to actually compute it fully. What don't you know?
What A is?
What A is. Yeah. Yes.
Wait, what?
So what she said is A could be, you get to pick what A is, and you want it to, this limit to exist. So essentially what's happening is that you need to pick an A such that the top factors, and so one of the factors is x minus 5. Does that make sense? So if you have ax squared plus 25 divided by x to the 5, and you want the top of factor with an x minus 5, what would A have to be out of these options? Yeah, so if A is negative 1, you'd have minus x squared plus 25 over x minus 5, right? And then the top factor. So essentially, when you're looking at this, the only way for this to exist is if this was a hole in the graph of the function, right? If it was an asymptote, it would not exist. So essentially, you have to force a factor of an x minus 5 in the numerator. So now we have a difference of squares, so we have x plus 5, 5 minus x over x minus 5, and this equals minus x plus 5. So that's why we need A equals negative 1, so that we can force it to be a whole. And that's the only choice that forces it to be a whole. Okay? So this is a bit more of a heuristic intuitional problem than actually computing it. But that's the point, is that you want to say, like, okay, for this limit to exist of this rational function, really the only way to rig it up is to make this a hole in the graph. And the only way for this to be a hole in the graph is for the top to have an x minus 5 or r minus 5 factor. Does that make sense? All right. Any comments?
Why wouldn't it be a equals 1, not negative 1?
Ah, so r squared plus 25, how does that factor?
Wouldn't it be r minus 5 and r plus 5?
So if it's r minus 5, r plus 5, if you multiply that out, the last term would be minus 25. So you want a difference of the squares, not the sum of squares. Does that make sense?
Mm-hmm.
Okay. So I recommend if you're when you're doing this on something like this on the exam, just check it. Just check your algebra. Just like undo what you just did, make sure it's the same. That's a very good way to check. So, does that make sense? This is a more intuitional problem. Do you understand how to evaluate this limit such that it exists? Any other comments? So moving on, we have fall of 15, number 11, horizontal asymptote. So I'll blow it up a bit. Okay. So here's a question. For a function, how many horizontal asymptotes can you have at most?
2.
2. Why?
Limit as x approaches negative and positive infinity.
Right, there's only 2 sides of it, right? So you have the negative infinity side and the positive infinity side. And you can probably rig it such that they can be different, right? Because if you remember that rational function we had on Wednesday, they were different. Yeah. So you can have at most 2 because there's only the positive infinity and then the negative infinity. Okay? So here you have at most 2. And that's why you see sometimes with 2 answers, here, and that's one of the critical things to remember here. Remember to check the negative infinity for an asymptote as well, because most people just start with the positive infinity. All of 15. Okay, so we have f of x is equal to e to the x plus 2e to the negative x over, so this is a very common one, I think, e to the x plus 3e to the negative x. Alright, so we have the two asymptotes. So we have the plus infinity one. So this one is, we need to compute the limit as x goes to infinity of e to the x plus 2e minus x over e to the x plus 2e minus x. Alright, so how do you do that? The answer is not L'Hopital's.
Oh, you divide by e to the x, right?
Yeah, you divide the top and bottom by e to the x. Okay?
Same tree.
Yeah, so e to the x, 1 over e to the x. Does everyone understand why this is the approach, not L'Hopital's?
Same tree, right?
Yeah, so the same degree is the degree of e to the x. So this is equal to limit x goes to infinity of 1 plus e minus 2x over 1 plus, 2 there, 3 e to the negative 2x. So that's equal to what?
1.
1. Why?
Because that goes to 0, so e to the
Yeah, e to the negative 2x goes to 0, right? So that equals 1. So this one gives you the horizontal asymptote. Y is equal to 1 at positive infinity. Does that make sense? Now we do the same thing for the negative infinity side. So you have the limit as x goes to negative infinity of e to the x plus 2e to the negative x over e to the x plus 3e to the negative x. Now what do you have to do?
divide by e to the negative x.
Yeah, divide by e to the negative x, because as x goes to negative infinity, this goes to infinity now. The issue flipped. Okay, so just doing this algebra quickly, so you have the limit. X goes to negative infinity. So if we divide by this turns into e to the 2x plus 2 divided by e to the 2x plus 3. So what is that?
2 over 3.
2 over 3, because now as x goes to negative infinity, e to the 2x goes to 0. So now you get 2/3, and then you have your second horizontal asymptote as y is equal to 2/3. Yes?
How do you know you have to divide by e to the negative x instead of e to the x?
So the issue is like, for instance, if these are like just x's and 1 over x, right? This one goes to 0 here for the positive one, while this one goes to infinity. So you're going to kill off that infinity in the denominator. So as he said, you divide by the highest ordered terms. Like if this was at an x squared, you divide the top and bottom by an x squared. So this is not polynomial, but e to the x is clearly the driving force here. So you divide out the top and bottom by e to the x. Does that make sense?
Yeah.
Okay. Likewise down here, if the issue flips, e to the x goes to 0, while e to the negative x goes to infinity as x goes to negative infinity. So that's the one you have to kill off. Alright. I just want to point out here, be very careful. Does L'Hopital's work?
No, 0, 0.
I mean, you can rig it up to be 0 over 0. Because for instance, this would be infinity plus 0 over infinity plus 0. Alright, so that's still L'Hopital's. Why can't you apply L'Hopital's, or why would it not be too useful?
You'll just keep giving e to the x.
Right, there's this e to the x's all over the place. The derivative would be e to the x minus 2 e to the negative x, and then this thing will just keep happening. So L'Hopital's is not a great option here, which is why you need to do it this way. Okay? So just keep that in mind. If you see things like cycling like that, so sines and cosines and exponentials are good ones that L'Hopital's like kind of struggles with. Alright, just keep that in mind. Alright. Did this make sense? Any comments? Origin, there's two asymptotes, and negative infinity is the other one. Okay.